In this video, we're going to talk about how to distinguish between discrete and continuous functions. So there are two different types of functions. There are discrete functions and there are continuous functions. So when you look at the graph of a discrete function, it looks like dots. So think discrete looks like dots. And that's because all of your points will be isolated somewhere on the coordinate plane. Continuous functions are all connected. So continuous, connected. And that means that you can draw your graph without ever lifting your pencil from the paper. And that is because all of the points are connected on a continuous graph. So let's summarize. Discrete functions look like dots. They include distinct numbers and not numbers in between the data points. Continuous functions are all connected, and you can draw them without lifting your pencil. They include an entire set of values. So let's look a little bit closer at this. Discrete functions can only be described using distinct numbers. They don't include the numbers in between the data points. So you can see here on this graph at x equals 2, y equals 1. At x equals 3, y equals 4. But none of these numbers in between these values are included. So let's think about a real-life application. If your graph was describing the cost of uniforms for players on a soccer team, why would your data be discrete? So the thing to think about here is, would you include numbers and then also the numbers in between? So the two variables we have are the cost of uniforms and players on a team. So for cost, let's think about it. You can include cost values like $2 and $3, and you can also include values like $2.50. But if we're talking about the number of players, you can have 5 players, you can have 6 players, but you can't have a number like 7.5, right? You can't have half a player on a team. So that's why your data would be discrete. So let's think about continuous functions. These functions include a whole set of values, not just specific data points. So if you think about it, if your graph was describing the path of a rocket over time, why would it be continuous? Well, if we're talking about the path of a rocket over time, so we have the path, and let's say that's described in meters, okay? So you could have a path saying like 2.5 meters, or you could say it traveled 10 meters. So you can include whole numbers and the numbers in between. If you're talking about time, let's say time is in seconds. You can have values like 3 seconds or 4 seconds. And you can also have values like 7.5 seconds. So in both cases, you can include numbers and the numbers in between them. So that's why your data would be continuous. So this would be like the graph of your path of a rocket. It includes all of the numbers and it's all connected. So how do you tell the difference? If you're given a situation and asked whether it demonstrates a discrete or continuous function, you have to ask yourself some questions. So first, does the function include a set of numbers? So whole numbers, fractions, decimals, are these all included in your set? If so, then your data is continuous. On the other hand, does the function include only specific values, like only integers? Then your data would be discrete. So let's look at some examples, and let's talk about whether these functions are discrete or continuous. So suppose we have a function describing the number of miles a person runs per hour. So in this case, we're talking about the number of miles and then hours. So miles, it would make sense to include whole numbers, right? Like 2 or 4. And we could also include numbers in between, like 3.5 miles. If we're talking about hours, we can include whole numbers like 1 or 2. But you could also say you ran for 1.5 hours. So this data would be continuous because it makes sense to include a whole entire set of values. So what about a function describing the number of books a bookstore sells per month? So in this case, we're talking about the number of books and per month, okay? So if we talk about books, we can include whole numbers for books, right? Like 1, 2, but can we really sell someone 1.5 books? We can't, okay? So that would not include numbers in between. We talk about months. We can say things like 2 months, 3 months, and we can also talk about half, right? You can sell books for 2.5 months. So although months includes all the values, because books has a restriction, this is going to be a discrete function. because you can't sell someone half a book or a quarter of a book or something like that. So what about this function? A function describing how the number of people in a household affects the total cost of groceries. So we're talking about the number of people and the total cost of groceries. So people, we can include whole numbers like 2 or 3, but we can't really say we have 2.5 people living in a house, right? You can't have half a person. So we cannot include numbers in between for people. For cost, we can include all kinds of numbers for cost. We can talk about $3 being the cost. We can say $13.75 is the cost. So it does include numbers in between data points. So however, since people is restricted, we're going to say it's discrete. So what about this function? A function describing the relationship between the amount of time a student spends studying and their grade in algebra. So we're talking about the amount of time studying and their grade in algebra. Well, let's think about it. So time, we can include any number of values. They can be studying for like 4 days. They can be studying for 5 days. They can study for 4.5 days. It makes sense to include all the numbers. What about grades? Well, you can have an 80 in algebra, you can have an 81 in algebra, or you can have like an 80.5. So it does make sense to include numbers in between. So in this case, it would be a continuous function. So in summary, discrete functions only include certain values. The values are distinct and separate. Continuous functions include a whole set of values.